Hi everyone! In this video I'll show you how to create a fire shader in Unity using shader graph. We'll be working with the fire texture we created in the previous video. Let's get started by setting up a clean folder structure to keep everything organized. Inside we will create a new unlit shader graph and open it. The first thing to do is configure the main shader settings and create a few parameters that we will definitely need. Main texture, color, power, intensity, and so on. Be sure to switch the color property from default to HDR, since this will come in handy later. Also, set some default values right away, for example, power equals 1. Next, we will sample our fire texture and multiply it by the vertex color. In Unity, this allows our material to receive color directly from the particle system. Before multiplying with vertex color, we'll insert a lerp between two colors using the grayscale texture as alpha. This way, bright areas close to 1 will take the main color, while darker areas will blend towards the second color. Since we don't need the alpha component of the color, I separated the RGBA channels, removed alpha and combined them back into a vector. Finally, we will multiply the color by a float parameter called intensity, so we can control the brightness later. That's the basic setup for the fire color. Now let's move on to transparency. Since our texture is grayscale, we can use just the red channel, which already contains all the information we need. After applying a power node to adjust contrast, I like to multiply it by another float parameter for extra control over opacity. At the end, always add a Saturate node. This prevents most common issues that can appear when working with alpha values and nodes like power. With the shader ready, we can now create a material from it and place it in a new folder to stay organized. To test the material, let's set up a simple particle system. I like to start with an empty emitter as a container for other emitters. Then I'll create a looping emitter that spawns one particle per second, and this will be our fire particle. Assign the material, plug in the fire texture and tweak the color until it looks right. Position the emitter so the fire appears inside the fire ball. To keep things neat, we can also categorize shader parameters. For example, group all texture-related properties together. At this point, we have one problem. The particle edges are still square, but fire should have softer, rounder shapes. To fix this, let's add a mask textures to control alpha. A simple soft circle like a bell shape works perfectly. The logic is simple. Multiply the mask with the alpha channel of our fire texture. Black areas of the mask, value 0, will make the fire transparent, since 0 multiplied by anything equals 0. This is why mask textures are so effective. You could also generate masks directly inside shader graph, but we will cover that another time. To refine the mask, we can run it through a power node, which lets us fine-tune the 0-1 range. Another issue, the fire texture and the mask don't align exactly the way we want. To fix this, we'll add parameters to control tiling and offset. Create two vector 2 parameters, set default tiling to 1-1, and then use the built-in tiling and offset node for the UVs. Now we can move and scale the texture freely. Let's make the fire more dynamic by panning the texture over time. We only want movement along the x-axis, while y stays fixed. To do this, split the offset vector, multiply the x component by time, leave y unchanged, and then combine them back together and plug into offset. This makes the fire scroll horizontally while remaining still vertically. If the mask looks too small, no problem, just scale the texture up to reveal more of the fire underneath. To keep the shader graph tidy, group related nodes into frames. This makes the graph much easier to read later. Now let's add more life to our fire with UV distortion. First, sample a noise texture and tiling and offset parameters, and animate it over time on both x and y axes. Multiply the noise by a float parameter that controls distortion strength. If the strength is 0, there is no distortion. Higher values give a stronger effect. Add this noise to the UVs of the fire texture. In the material, assign a noise texture with large shapes for the first layer of distortion. This makes the fire softly warp and flow. You can even try negative values for the distortion strength to get interesting results. For even more detail, let's add a second layer of distortion with its own parameters. Just duplicate the setup, give it different tiling, offset, speed and strength, then blend it into the UVs as well. This gives the fire two levels of motion, larger flowing shapes and smaller quickened distortions. Adjust the parameters to make the fire either calm and smooth or energetic and chaotic. As always, material tuning is all about experimenting. We might also want to move and scale the mask independently, and instead of adding new parameters, simply enable use styling and offset directly on the texture property. This gives you built-in controls, so you can't animate them over time. Finally, play around with the particle settings, change the size, position and lifetime until you're happy with the result. One last thing, just like we multiplied our color by the vertex color, we also need to multiply alpha by the vertex color alpha. This ensures our material can read particle transparency values from the emitter. In this example, we won't be using particle color over lifetime, but this step is essential in many other cases. Here are my final material settings. Of course, these are just my preferences. Feel free to adjust everything to your own taste and needs. And that's it! We've built a complete fire shader in Unity shader graph from the basic setup to adding distortion, masks and movement. You can keep experimenting with parameters, textures and particle settings to achieve endless variation of fire, from calm campfire flames to intense magical effects. If you found this tutorial helpful, don't forget to like the video, subscribe to the channel and check out my previous lesson where we created the fire texture itself. Thanks for watching and see you in the next video. Bye bye!